Okay, this may be a longer video than general. I'm going to do what I would perform for mini project 4, which asks you to do a hypothesis test on one sample and then a comparison sample of some sort. So I've decided to take, and this is true data from our class. I took the scores of all the students who have taken calculation quizzes up to this point. So there's 49 pieces of data here. And then I separately went through, dug through, and found the scores of all the students that took the calculation quiz only one time. There were 17 students who took that option. And then I took the scores of all the students that took the calculation quiz multiple times, which was 32. Notice 17 plus 32 is 49, so I did indeed get all of your information. So now, let's perform for my one, what I was calling my one here. I'm going to perform a hypothesis test. And I already looked at the average, so I saw that the average was somewhere close to about a 70%. So I guess what I would be interested in here for my first case would be to say, I would be interested to see if the average score of all students that take calculation quizzes seems to be below 75%. Let's run a hypothesis test to check this. So my 1A would be a place where I have to set up my hypotheses. So I'll go H sub 0 would be the hypothesis that the actual average mu equals 75%. Well, on a test, let's see, our quizzes are out of 20, so that would mean like a 15 out of 20 would be 75%. 75%, let's come over here and see. 75% of 20 would be a 15. And I'm going to test that against the alternative of H sub A is an average score mu, which actually ends up falling below 15 out of 20. Okay, so when I come over here to the calculator, let me clear it very quickly. You can see that in the stats, I've already set up my editing of the lists. So I have L1, which is all the data from over here, 8.1, 8.4, 13.4. And then the students who took it only once is right here in L2. And the scores of the students who took it multiple times, 20, 15, 6, 19.2, they're already recorded inside of my calculator's memory. So I'm just going to run the hypothesis test. I'm going to do a t-test because we don't know the true standard deviation. I'm going to use the data that is located in list 1. I'm going to test the hypothesis, the null hypothesis of 15, against a one-tailed test, which checks to see if we're actually in reality less than 15. So when I calculate this, it looks like I am getting a score of a t-score. My statistic would be t equals negative 1.6024, which has its p-value, and the p-value is a 0.0578. Okay, notice this p-value here is small, 5%, but it's not less than 5, and it's not less than 5%. It's a little bit above 5%. So that's bigger than 0.05. And that means I don't quite have enough evidence to reject. So my conclusion is going to be I failed to reject my null hypothesis. I do not have enough evidence to conclude that students perform less than 15 out of 20 on my quizzes. So although the scores were lower than I hoped, they're not significantly lower. They're actually relatively close to the truth, or relatively close to what we hoped for. Now, 2, notice that I failed to reject my null hypothesis. So my potential error would be a type 2 error. I may have made such an error, because typically my cutoff level is around 5%, and my p-value of 0.0578 is just barely above 5%. Okay, the second alternative was to test to see some differences. So here's how I'd run my differences. I would say the average score of those that took the test twice or more seems to be higher than those that took it once. Let's run a test to check this. So in this instance, I have 2 independent samples here. So in this case, my alternative, or my null hypothesis, h sub 0, would be something like saying mu sub 1 is equal to mu sub 2. In other words, I'm presuming that the 2 hypotheses, or the 2 means of the 2 groups, those who took it once and those who took it twice, are essentially the same. As opposed to an alternative, which would say that mu 1 is actually not equal to, let me see if I can find a good symbol for this one. Math equation not equals to mu sub 2. Okay, let's go run a test to see how this works now. Remember, my L2 is mine who took it only once, and L3 was those who took it multiple times. So when I come in here for this t-test, let me clear my key press history. I'm going to come over here and calculate a test. And this time I'm going to do a 2 sample t-test, because I have 2 groups that I'm trying to compare with each other. I'm going to insert data. The data for my first group, which would be those who took it only once, would be L2, those who took it only once. And then my other group would be those who took it more than once, so that would be my L3. I'm going to rush over here and change this not equals, actually, because I actually think that students who take the quiz more than once are going to score higher. So I'm going to have my mu1 be less than my mu2, because mu2 was supposed to be the group who took it more than once. Okay, so I'm testing mu1 less than mu2. We never pool here because we don't know what the standard deviations are like in the background. And then I'm just going to simply calculate. And let's look at that. Okay, so now we're getting a t-score, or a t-statistic, that appears to be about negative 1.5594. Oh, darn, I didn't run this beforehand, and I was hoping that I would have significant evidence, but it turns out that my p-value this time is only a 0.0651. Notice that this is also larger than the standard cutoff level of 0.05. So this is not really rare enough. So yet again, I fail to reject my null hypothesis. I do not have enough evidence to conclude that taking the quiz more than once will yield a higher score than only taking it once. However, I'm still confident we still have one more calculation quiz to go, so we'll see how that last one turns out, eh? Okay, so with those steps now, I guess my potential error here is, again, because I failed to reject, is again possibly type 2. Hope this helps. Thank you very much.